Good morning, everybody. Welcome back to lecture number 8. Today we started the lecture by doing exercise, which is a wake-up call for you to study. The exam is in 13 days. That's why I want you to study hard. Nodal voltage is a guaranteed question in the test. What happened? That's why it's a guaranteed question in the test. So to solve this problem, you always need to, and I want you to focus with me how to solve this checkpoint. This checkpoint asks for I1. So let's start. What's the equation of I1? I1 equals V1 minus V2 over 10, right? So once you know V1 and you know V2, you should be able to calculate I1. Now, for the drawings, I want you always to draw the circuit properly. And what did I tell you about this circuit? Is you always have to draw fake arrows. صح ولا لا? That's why it's a standard process, because you have to draw fake arrows. So we call this IA, we call this IB, we call this IC. Yeah, I know it says I1, but don't confuse yourself. أحسن تحطها A, B, C. For node V2, which is the node that has a voltage drop of V2, the ground is here. Do not move the camera, please. That's okay, it's a fake quiz. Doesn't matter. We said ID, IE, IF. That's the key. What did I tell you about the equations? You have to, we said key thing in nodal voltage analysis is we say in equal out. When we say in equal what? 0. All the nodes are leaving. Tamam? 0 equals IA plus IB plus IC. This is what? At node V1. And 0 equal I D plus IE plus IF at node V2, صح? Any question about until this step? This is a standard, okay? Now, the way I told you, what is IA? IA is actually minus 1 amp, right? 1 amp goes from here to here, direction of the arrow. Current source tells you the direction of the current here is 1 amp, so IA is minus 1. So you will have minus 1 plus. What is IB? IB is V1 minus 0 over 20. V1 minus 0 over 20. What is IC? Please do not move the camera. What is IC? V1 minus V2 over 10. Remember the key. Where the current plus minus over the resistance. The current is plus the potential difference over the resistance. Ohm's law. For those who are putting plus or minus sign, do not confuse yourself. Don't put plus sign, then you have to put plus sign there. You'll confuse yourself. In this standard process, I do not recommend you putting plus or minus in the directions of the arrow, okay? على resistors, you only put it over the nodes only. بمعنى, only V1 and V2 you put the signs of it. Because we already know it's leaving, so this voltage minus this voltage over. Remember guys, always remember this equation. I want you to put this as the wallpaper of your phone, okay? Remember this equation? Now, going back, what should we do? Equal to 0. 0 هذه هي ال N. This is equation 1. What is equation 2? What is ID? ID is V2 minus V1 over 10. V2 minus V1 over 10. What is I? E.
It's
V2 minus 0 over
5.
what is the last one? Minus 2 equal to 0. Many of you started moving things early. Do not move things early. When you go to the standard form, then you move the stuff. Again, it's a standard process. It's a guaranteed question in the test. And this question will be in homework too. So now you solve some of the homework. Now, how do we write it in the standard form? We do a matrix, then we do V1, V2 equals something. What's the size of this matrix?
2 by 2.
2 by 2. If it was 3 voltages, what's the size?
3 by 3.
If it was 4 voltages?
4 by 4.
If I bring you a question in the test, and I tell you, just quick question, how many nodes, what's the size of the matrix, and I tell you that you need to calculate 4 voltages, are you going to be able to say it's 4 by 4? Yeah. We will not give you a question in the test where you have to solve a 4 by 4 equation, okay? The maximum is 3. Now, what is the, okay, we have 1, 2, 3, 4. What is V1? 1 over 20 plus 1 over 10. 0.3, right?
0.15.
You're right. 0.15?
Yes. Then the second
It's
one.
1 over 20 plus 1 over 10. And then we have minus 0.1. Then we have the minus 1, we move it here, it will be
Positive 1.
plus 1. Any question about how we wrote the first row? How about the second row? Minus 0.1.
Then 0.3.
For V2, what we have? 1 over 10 plus 1 over 5, which is 0.6, right?
0.3.
0.3. Equals
We move the 2 to the other
2.
side.
Calculator.
Then we have V1 as 14.28.
14 volts. In the quiz, I didn't take off points for the unit, but next time I'll take off points.
The second one is 11.42.
Did you guys get the same answer? Yes. Okay. Clear? This example, I'm not going to solve it, but I want to explain to you. It's not a problem, it just tells you. Here, we already know V1, right? So are we going to draw fake arrows away from V1? No. So we draw fake arrows at V2 and V3. In this example, he did not rename the node. He kept them V2, V3. Okay? And it's clearly V2 is and then inequal out, so it's IA is V2 minus V1 over R2. IB is V2 minus 0 over R4. And the last one is V2 minus V3 over R3. That's equation 1 at node 2. Equation number 2, V3 minus V1 over R1. V3 minus VR2 over R3. V3 minus 0 over R5 equals 0. Do I need to include this equation in the standard form?
Yes.
No.
We have 3 unknowns.
No, we have 2 unknowns. We already know VS.
Okay.
Well, it's now, do you know R2?
No.
It's the same thing. Alas? Yani this is just a problem that deals with variables, but in reality, you do not include VS here because you cannot calculate the current here. That's the reason. There is no resistor where you can divide over. So do not include it in the standard form. So the standard form includes only 2 equations. And I'm going to write it in the standard form. How do we write it in the standard form?
V2 over.
Okay, what are the coefficients of V1? It's minus 1 over R2.
Yes.
Now, keep in mind that V3 is going to be treated as constant.
For V1 to be constant.
Oh, V1, you're right. V1 is treated as a constant. So we have here V2 and V3, right?
Yes.
Now, I'm not gonna do it because it has too many variables, but the key here is, for V2 you have 1 over R2 plus 1 over R4 plus 1 over R3. For V3, what do you have? Minus 1 over minus 1 over R3. For node equals to what? Equals to 1 over R2, and then you include the V1 here. V1 is constant, not variable, okay? This is a constant, it will be 5 volts. So in a numerical example, this will be 5. For the second row, it's clear. Minus 1 over R3. And then you'll have 1 over R1 plus 1 over R5 plus 1 over R3, and then equals to V1 over R1. Keep in mind, no, it's plus, you will move it to the right. All the constants, you move them to the right when you write the standard form. Get it? Is it clear? Is nodal voltage analysis clear to you? Did you benefit from the exercise? The fake quiz? Was it a good wake-up call? Okay, so now you know how to do it. And you already solved one problem in the homework.
That's all. When we use this method?
You cannot use this method if you have too many voltage sources. So if you have if you have too many voltage sources, you cannot. But in the exam, we will try to give you a hint which method to use. But for now, if you find big circuits, then it should work with it. Don't use it for a simple circuit. Okay? We're done with the nodal voltage analysis. Today we will explain mesh current analysis. We'll have this lecture and next lecture, okay? But let me take a break. One of you asked in the private responses, I do not have the courage to study. Whenever I open the book, I find myself not happy. How to overcome this? I can tell you one ugly truth in life, okay? How old are you? 20, let's say 20, maybe most of you are 20, صح? Retirement? 62 or 50? 62, right? So basically, عشان تاخذ التأمينات, you need to work how many years? 42. 42 years of work. So if we're gonna draw a curve about, difficulty, many students say, oh, it's very difficult, it's gonna get easy after graduation. So maybe when you're 24, I got a job, خلاص, alhamdulillah. Well, it is true for some people, but in reality, what I have observed is difficulty is here, and then it will start become very difficult, and then maybe around 40 it gets very easy until you're close to retirement. That's how your effort should be put in life, okay? So around between end of 20s, early 30s, you should work very hard. So now you also should work very. So if you cannot do this, it means you're, okay? So my advice to you is understand that the higher this curve now, the easier it is to move in life. 42 years, the sharp is too much. And here 3 years, 4 years. Okay? So once you have this figure in mind, you will stay motivated. And you have to stay motivated, ya shabab. If you don't invest in your knowledge now, it will be very difficult to maintain this success curve. خلاص? So my advice to you is do your best. I know it's hard, I know it's difficult, but do your best. خلاص? وفي نصيحة, يعني you don't have to make everything perfect. Sometimes it's better to submit the homework and you have another homework to do. just submit what you have and move forward. خلاص? Study hard, okay? Nodal voltage analysis. When do we do nodal voltage analysis? Answering your question, how many voltage sources we have here? Two. So if we do V1 minus VB over R2, V1 over R2, we can solve it using nodal voltage analysis. But there is an easier method. Many students hate mesh analysis. What's the definition of mesh? Mesh يعني? Mesh. What is mesh?
We take it in fluid. It's mean like.
It comes from shabaka. So it means a grid, صح? Network. So you can think of it, it works if you have too many loops. If you have too many loops, it works. This is another technique. If you have, it's a general technique, it should work elsewhere. Branch currents, using mesh currents makes the solution easier. So in this method, you have I1, I3, I2. This is chapter 1, right? This method tells you, oh no, I'm not going to have 3 currents, I'm going to replace them with only 2 currents, I1 and I2. So, for example, if we put plus minus, do you guys see I1? If the current that goes here is I1, do you see it's equal to this I1?
No.
No, it does equal. Now,
Yes, because
in a resistor, in the mesh, I do like this, A1, and this is fake current, okay? And then I do I2. So in this resistor, I have I1 moving here, I2 moving there. Keep in mind this I1, this one is in blue, not in black. This I1 is in black. This I1 is in blue. This I2 is in blue. So I3 equals to I1 in blue minus I2 in blue. Do you see it? Do you see I3? If I tell you there is a current of I1 moving across this fake loop alone, and there is an I2 that moves across this fake loop, including R3. So at R3 we have I1 moving from top to bottom, I2 blue moving from bottom to top. So this tells me I3 black is I1 blue minus I2 blue. Get it? So this implies I1 black equals to I1 blue. And I2 black equals to I2. Get it? Again, it's like IA, IB, IC, fake currents. It's not real. It is the same, but the key here is I3, we got rid of it and we replaced it with the KCL. So it's similar to KCL. If you do KCL, it's like that. But don't confuse yourself. Draw the fake current using the circle, okay? Counterclockwise.
So, how can we draw the I3? How can we draw I3 for this using mesh method?
Well, if you use mesh method, okay. I3, we replace it with 2 big blue currents, where I3 is I1 minus I2. It's fake. The blue is fake. It's not real. What's real is the black. The black currents are real. We replace them with virtual. Virtual يعني إيش? Fake. It's another way of saying fake. Fake currents. Actual currents, fake currents. The IA والIB والIC في node V, for nodal voltage, they were fake currents, صح? We pretend. So here we pretend that it's a circle, it's a circle. The key here is إن أنت كأنك تقسم الدائرة ل 2 different systems and you solve for them. How to do it is you assign mesh currents clockwise direction, I1, I2, apply KVL at each loop. Your current of interest is the positive current. So when we apply KVL, now let's forget about point number 3. We'll explain it later. When we apply KVL here, and I'm going to do a simple circuit. So you have here plus minus VA, R1, R3. So I1, what you're going to do is you have to look at this system alone. Forget about whatever on the right. And then you have to draw the other one here. So you have I2 and you have I1. Now, to make things easy, do you want me to call it IA or IB? You think it's better to call it IA, IB? Let's call it IA, IB to make things fake. So this is IA, this is IB. Who wants to be the KVL? You will be KVL. Here, and you have to start here. Okay, now, before you start KVL, put plus or minuses for the resistors according to the directions of the fake mesh current. So this enters here, so plus minus. This enters here, plus or minus. Oh, there is a problem. IB enters from negative and plus. Keep it. IB plus minus, okay? So this is R2, R1, and then you have R3. So doing KVL across this loop, voltage rise, voltage drop. Plus V. Voltage rise, voltage drop. Minus IA times R1. Voltage rise, voltage drop. Drop. And here's the thing, minus. What is the current that goes through the R3?
IA minus IB.
It is IA minus IB. So the current that goes here is actually IA minus IB. Get it? So this was in the chapter 1, this was I3. Get it? This plus this plus this equal to 0. So this is KVL, Kirchhoff voltage law, at loop 1. So this is loop 1, okay?
Multiplied by R3.
You're right, R3. This is loop 2. So let's do the loop 2 thing. How to do loop 2? Again, who wants to be the KVL? Srabu. Voltage, go this way. Voltage rise, voltage drop. Minus V. You're here. Voltage rise, voltage drop.
Right.
Plus. And what's the current that goes here? IA minus IB. Do not say IB minus IA. You already assigned the positive polarity here and the negative polarity here. And you already assigned the current here. So these things are techniques for the mesh current. So go with the process. It's IA minus IB. It's a voltage rise. Here previously it was a voltage drop. Times R3. And then here.
Drop.
Minus. What's the current?
I2.
IB. Times R2 equals 0. Now let's organize everything. Now it's the same equation, except here we replace 1 with A, 2 with B, and then the book, one thing I don't like about the book is they start putting things to the right and the left quickly. Do not go with this process. YouTube, go with this process, okay? Get it?
So this is just a combination between KVL and KCL.
Yes. So KVL and KCL, it's baked in، مخبوزة داخلها. مخبوزة في داخلها وين؟ في الKVL هذه، ومخبوزة داخلها وين؟ هنا. It's baked in. برضو nodal voltage analysis. It has KVL, it has KCL. مخبوزة baked in. يعني متخبية بشكل غير مباشر. هذه techniques. لازم تمشي على process. أي حياد عن هذه البروسيس it's gonna make your life hard. So I think you should go with this process and then you organize everything. So you solve, what are the variables? You solve for IA, right?
Yes.
Let's try to, so 2 equations, 2 unknowns, let's put it in the standard form. How do we put it in the standard form? We put IA and IB, right? What's the size of the standard form matrices? 2 by 2. What are the coefficients? Okay, if you get confused in the test, you should put lines here, okay? So now we do for I. What are the coefficients? Minus R1 minus R3. Do you see it? Minus R1
Plus
minus R3.
plus or minus.
It's a minus. So minus R1 minus R3. For IB, so that you don't get confused, put a line here, put a line there, put a line here. It is plus R3. That's it, right?
Yes.
This is R3. What is the constant here?
minus VA.
We move VA here. It's minus VA. Now in the example or in the test, maybe VA will be a number. You already should know it. It's a known voltage. But now I'm explaining the process. Equation 2. It's minus R3. No, what's IA? Put a line. We already, okay. Put a line here, IA. What is the coefficient?
R3.
Anybody who doesn't see R3 is the coefficient of IA? Raise your hand. It's R3. Hatem. You see it? Watch YouTube. Okay? It's this is another guaranteed question in the test. For IB, what are the coefficients? Minus R3 minus R2. And what is the constant here?
Plus VB.
Plus VB. One student asked me how to verify my solution is correct. Go through your process again and verify the signs. Most students have mistakes with the signs, and then you will find it in one of the questions. I personally, I don't know about Dr. Atiyah, but when I write my tests, I don't care. I just put random things and I put the correct answer. I'm not going to mislead you. Any question about the concept? I'm going to explain it one more time عشان تعلق في المخ. In mesh analysis, we assign fake currents. Virtual يعني fake. We call them IA and IB. So IA is actually I1 in the original system. IB is I2. Everything is clockwise. However, I3 is actually IA minus IB. IA minus IB. Okay? The key here in the method is after you assign the currents, you do a KVL. You do a voltage rise, voltage drop, voltage rise, voltage drop, and usually the resistors where there is two currents meeting each other, you will assign plus minus, and then you put the polarities as I told you before, plus on the top, bottom at the, negative at the bottom, plus at the left, negative at the right, if he doesn't tell anything. And then you build on it the directions. Now, I'm not going to solve this question for now. I would rather solve this numerical example. Okay? Now, this is another system. No. Okay. One thing about the wording here. What does reference upward mean for R2? Hatem. I have R2 here, okay? What does reference upward mean? معناتها البلس فوق والنيجاتيف تحت ولا النيجاتيف تحت والبلس فوق؟ reference upward.
بلس تحت والنيجاتيف فوق.
reference upward ايش معناها؟ يعني voltage rise to the top. يعني plus minus reference upward. لا معلش sorry. I get confused about it in the book, but reference upward يعني الريفرنس هو المرجع. What is the reference اللي هو lower voltage؟ فالنيجاتيف هي. reference upward يعني كده.
So كيف اللور فولتج يكون هو
It's similar when I tell you the battery has 5 volts. Where is the reference? Reference is here. صح? This is the same language. So for the resistor, when they say reference, it means the salib. Here, reference on the right, R4. Where is salib? Plus, minus. Here, reference downward. Plus, minus. واضحة? This is a confusing language in the book.
It's like the conventional current is going upward.
No, it has nothing to do.
Not the-
The reference is the voltage reference.
I know, but the voltage, the current that we solve for will be going upward.
Unnecessary suffering.
But it's easier than thinking.
Well, الريفرنس هو المرجع.
If we have plus at the bottom and negative.
You can leave if you want.
The current will be going upward.
Take a
So
quiz.
what we are solving for will be
Your quiz, take it. Take a quiz here. معلش, sorry. Only take a quiz here. Take your quiz with you. Attendance. For latecomers, come and see me. Nakhli, what was your question? تعال. بالعربي ايش؟
قصدي إذا نشوف إذا نقدر نلعب عشان بلس ماينس
That's another way.
يعني أنا أشوفها أسهل من البلس
الريفرنس هو السالب اللي هو اللور مرجع حقه. انت لما تقول 5 فولت الريفرنس حقه سالب. تذكر مثلا البطارية. Where is the reference in this battery? أين هو المرجع في هذه البطارية؟ الجراف. أين هو المرجع اللي هو السالب؟ I think this is easy. على كل I'll try to avoid this question in the quiz. I'll try it, but not guaranteed. Late, صح? Any question?
Yes.
Yeah, come.
About the fake current, we go clockwise, right?
For the fake current, we go everything clockwise.
But if the current go to the left, can I make it counterclockwise?
It doesn't matter. The fake current, all of them clockwise. أنت تسوي لها الساين. وقلنا إحنا always الكيفية clockwise. كل شيء clockwise.
يعني ما أقدر أخلي واحدة clockwise.
You will confuse yourself. لو تقلب I8 تصير كذا تسبب مشاكل. Don't do it. Okay. Stop the recording.